Okay, so today's topic is about using version control with Git. My name is Feng Chen, and I'm a manager of user services. And this talk has been taught previously in in fall semester in last year and the workshop. So basically, as I mentioned earlier, this is a very fundamental introduction to help you to start with using a version control system using Git. If you have previously worked with some other version control system like Subversion, Mercurial, or CVS, you might see some similarities in here, but using Git is the most popular version control system at this moment. So I hope this talk can give you not very comprehensive one, but give you a good start of how to use the version control to track your changes. So let's first go to the first slides. I want to give you an outline of today's talk. So first, we were going to give you some background, why we need to use Git. Second, we will talk about how to run Git locally. So basically, it is going to teach you how to travel, how to create a version history, how to travel through your working history. And by working with the local Git, by traveling through the version history, you will have a basic understanding of Git's fundamental concepts, like the staging area, like the repository, how you change, how you make a change, how you travel through different change, how you revert a change, how do you revert to a specific commit. So that's the second part of how to run Git locally. Third part is how to work with Git branch. And this is the major advantage of using Git. And some of you, if you have used the other version control system like Subversion, you will feel that creating a branch is not easy as using Git. And in Git, creating a branch is so easy. And last one, we will talk about working with remote repository. Many of you probably working with some kind of software already posted on website and they use GitHub or some other cloud version control system to store your software like Bitbucket. And you will have the opportunity to learn how to work your repository with cloud-based, web-based remote repository. And that's actually the last part, and I think it's pretty easy to follow. All right, so this is the basic 1, 2, 3, 4. We have major 4 parts, and hopefully we can finish the whole 4 parts within 2 hours. Now, the first question we try to answer, which is the first part of today's talk, is why do we need a version control system? So how many of you already worked with a version control system before? What did you use? GitHub. GitHub is a website. It's not a version. Oh, Git. Okay. You? Subversion. Okay. Git. All right. So you probably have some fundamental knowledge about it. But we will still start from the very beginning to compare different version control systems, introduce a little bit about the history of the version control system. So you have a basic understanding of why we use Git today. So this is not a history class. So we're not going to spend a lot of time about who created Git and the why Git come into place, why Git have this name. We are not going to talk about that way. We're going to go through the history, a little bit history of version control system. Then we talk about why Git becomes so popular nowadays. Since some of you use Subversion, some of you use CVS. CVS, yeah. So why we are nowadays we are using Git instead of using CVS? That's the question we try to answer. All right. So for those of you who have never worked with a version control system, so let's first think about a scenario. Now, graduate students or postdocs, during the entire your work in LSU or some other institution, what is your job? Your job is going to finally create, you might be working on a numerical simulation project. And you are supposed to do what? You're supposed to edit a series of text files, right? You're editing your input if you're doing a finite element analysis. And what you do is you edit the input of a file and you change it. Probably today your advisor came and asked you, you need to implement this function, and you work on it. And now you have a version and it works. It is good. It's something you want to save. And the other day, your advisor comes the next week and tells you, okay, you need to implement this function. And this is another function. And this involves you to change the previous versions of your input from last week. So typically, before we have a version control system, what we do, as I have done in my undergraduate study when I was writing my first source code, working on the first project, what I do is something like this, right? Probably everybody, if you have never worked with a version control system before, you probably have this very bad experience. Now you mess up with your names. You're running out of your names. You have your my input, this is the first one, and later on you have, okay, this is final, and this is final good. This is final input good, improved. Now I messed up, I need to add the data on that. And then I need a no change, I cannot be changed, okay. Maybe you're working at a company and your client coming ask you to do this, do this, do this, do this. And you have different functions and you have different versions. Now it's messed up. This is actually the very fundamental intuition of why we need to have a version control system, because the copy and rename approach, it is very simple, definitely very simple. Everybody can use it as long as you know how to click the mouse, you know how to use it. Right? You don't need any fundamental advanced knowledge about the computer. You need to, you can use it. And actually, we do see still a lot of people that when they are releasing their software, a lot of professors, they releasing their software, they're on a website, I see something like this. Implicit, explicit works fails and TGZ is something you will see, but it is a very bad habit. It's very simple to use. Everybody know the way, make a copy and rename it. But let's look at its downside. It's incredibly error prone. It's so easy to make mistakes. It's very difficult to manage. You need to have a super powerful brain to be able to manage so many names. And if you want to compare differences in history, it is also very difficult. And if you want to collaborate with your lab mate, collaborate somebody else in other institution, how do you do it? If you simply use the copy rename approach, it's almost impossible for you to achieve this. And actually in early days, still people do this. In the very early age, even when Linux worked with the Linux kernel development, they were using this approach by copying and applying different versions of patches. They're still working this way, but it's very error prone. It's so easy to make mistakes. So we here has the level of version control system, and think about level 1, copy the line and comment out. This is level 0, and level 1 is what? The copy and the rename approach. And level 2 is you have a backup system. Every time you have backup now and then, you might have an automated script to help you work with this. Okay. And also you have the third level. Okay. The third level is you have an external server. Maybe you are still working in a company, but they have like a standardized backup workflow. They have a system to work on your backup, but backup is still not version control system. At a certain time you do a backup, you might miss a lot of changes in between those backup points. Like if you have a Windows backup of your different restart points, and it's very easy to miss any changes between them. Now the fourth and the fifth level is something I want you to achieve at the end of today's training. I hope you can know how to use a public Git repository and a private repository. It's very easy to use. You will find it's actually much easier than we talk about in today's training. So we were not going to focusing on how to use the GitHub repository on the cloud. We will be focusing on how to use Git locally, how to work with different version history, and that's fundamental. But we want you to have the good understanding of those concepts. All right. So if you mark yourself at this moment, which level are you? Most of you probably at the level 1, hopefully. I hope if you are at level 1 now, I hope you should be at level 4 after 2 hours. Okay, so let's talk about, still we are in the background part. What is a version control system? So the definition here is a specific definition that version control is a system that records change of a file or set of files over time so that you can record specific versions later. In simple, it is a system that records and manages of your changes so that you don't need to worry about how to manage the change of the files by yourself. The system does it automatically for you. And the only thing you need to do is to do how to use this system to manage different versions. So here's also some very fundamental introduction about the version control system. So what version control system can do for you. So the first is a version control system, VCS. It can record changes. So you can travel at different versions, specific versions later on. You can revert to different versions, and you can compare your changes over time. And you can also see who made the changes. That is so important, because if you're working in a group and every group is committing their changes to the repository. I use the word repository, and we'll explain what is repository later. So basically, repository is something that you put all the codes, everybody's work together. And it's important to track who is making this change, who is making that change, and who, if you are boss, standing on top of the group, and then you need to see who has the better performance and who make the mistakes and bugs all the time, and you need to fire him. All right, so this is very important. Who made changes, at what time, and what kind of changes did he make? And if you're using the simple copy rename approach, it's not possible to do that. So any plain text file works for the version control system we are talking about in today's training. So that's something you need to make clear. We will not be talking about how to work with version control, different version control with binary file. If you have a binary file, there are some other choices, but this is not something we will be talking about in today's training. So that's out of the scope. If you use Dropbox, if you use Box, it's currently available for LSU. They might have some version control capability as well, but it's not something we will be focusing. We will be focusing for plain text ASCII file. It's if you have a LaTeX file, text file, input file, configuration file, input file for a code, and that is something we will be focusing on. We will be focusing on plain text ASCII files. So we'll talk about the advantage. First, since it records and manages the changes well, it's very easy for you to recover from mistakes. And it remember what you did for you. It's very easy. And It's easy to use and it's very difficult to lose information. So it's basically it's very liberating. So if anybody have any questions, I think we just focusing on what is a version control system. We haven't got to the actual why we use Git today, but we here emphasize why we need a version control system, why we have to use it. Because anytime since you are working with different versions of your file, and you change your file over time, and you work on the file over a couple of years, it's very important to track the history of your file. Especially if you are working with a research project, you work with a research project over time, you need to have different functions. It's so important to have the version control system. Now let's go to a little bit about the history of version control system. And we will explain why Git is so popular nowadays. Basically, the type of VCS is also related to the history of VCS, version control system. So there are different types of version control system. The first type, what we call the local version control system. Everything just simply standing on your laptop or on your desktop. It's local. You make all changes on your laptop, edit the file, commit changes. Everything is on your local laptop. And it's should be simple, very simple to use. There is a disadvantage. What is the disadvantage of that? You can think of. If your hard drive fails, okay, then you missed. Second, if you want to collaborate with others, it's very difficult because it's only stand on your local desktop. Now, so this comes with the other version of centralized version control system. And representative software, one is a Subversion, one have used here. The other is CVS, is even have a longer history, centralized version control system. So this concept is like computer A and computer B. Both of them, all of the clients, they commit their changes to the centralized version control system server. So you have a server standing in the machine room. As long as you guarantee the safety of this server, everybody can commit their changes to this centralized version control system server. It's actually relatively easy to understand. So everybody in a small company, everybody just, you have a centralized version control system set up, and everybody just commit their changes to the centralized server. And when you make some changes, you commit it. And when you want to retrieve other people's changes, you just get those changes from the server. You don't have to talk to computer, as you are user A on computer A, you don't have to talk to computer B directly. So this is the difference from the localized version control system. It's centralized. It can have lots of advantage over the local version control system. But this also has a disadvantage, and anyone can think of what is this advantage of using the centralized system. Okay, in 2016, we have a big flood. And if your machine room hasn't to be flooded, what's gonna happen? Everything fail, okay? And okay, as an employee, I'm not managing the server. I have the excuse of not working for a couple of days. Okay, so this is actually will have the danger of you still losing information. And once the centralized server is down, it happens all the time. Not all the time, it happens, can happen very frequently if you have a bad internet connection. In many cases, you can out of luck. So that's why distributed version control system and Git as one of them becomes so popular. So each server, each computer, they have a complete copy of all the version control system. All it contains all the copies of the version history. So even the centralized server fail, as long as you have your localized repository, you can still recover all changes. Even if you don't have an internet, you can still working with the version control system. You can still commit, you can push changes, and you can pull up changes. As long as you're internet ready, and then you can communicate with the other entities working on the same group. So that's the major difference between the localized version control system, centralized, and distributed. And nowadays, most of the systems, they try to implement this distributed version control system idea. So all the entity has a complete copy of the version control system in the repository. As long as you pull out the repository, it's a complete copy of everybody's work, of all your history. So the advantage of using this DVCS, distributed version control system, you don't need an internet connection to interact with the repository. And every clone is a real full backup of all data. If your server dies, you can still, you still need to work, okay? You still need to work with the Git. You don't have the excuse of stop working. Even if it's flooding, as long as your laptop is alive, you still need to work. Okay, this is a disadvantage for employees. Okay, and because it's also support multiple remote repositories, you can collaborate with different group of people becomes extremely easy. And this is a major advantage of using DVCS, but this is not actually the focus of today's training. So here, I just put it here so you know that this is a great advantage, but we will not talk too much about it. All right, and the last slide before we end the background part is the history of Git. So as I said, this is not a history class, but Git, this software was created by the founder of the Linux operating system, he wrote it. And also put here the why it was named Git. Go to this link on the slides to figure out if you're really interested. I'm not really interested in that. So this is something that you just want to learn, right? So far for the background part of why we need a version control system and why we need a Git. Anybody have any questions? And we will be working with the terminal for the next few parts, and you can also refer to the slides during my work with an example working repository. So we will be starting the second part. Run Git locally on your laptop or desktop. I will be demonstrate my creation of a local repository on Supermicro 2 cluster. But it's okay for you if you just want to work with your laptop, if you have a Git installed, if you can open the Git command line interface. And you can follow what I type on the screen. Since I myself use use Windows. So if you have the Git bash installed after you have installed the Windows version control system, you can type the same thing. If you can open this terminal Git bash, you can type Git version, something like that. It's perfectly fine. But please, during today's training, follow my terminal. You don't have to type. I just want to think regarding the procedure of I made changes, create a history. So as long as you think, you understand the concept. I don't want you to stuck at a single point. How do I edit a file? And that's not my focus. All right. So please pay attention to what I type on the screen. For the remote users, let me see how many. Okay, there's only one remote user. So for remote user, if you please also follow my screen about how to create and change a local repository, how to work with it. So on Supermic 2, we first already have the version control system installed. If you use the module command, we already have the Git 2.17 installed. I think the slides we use today should work with a very low version of Git. Even if you use a Git version as old as 1.8, it should still work. So don't worry about if you don't have a very latest and greatest Git version installed. There's no problem. Our commands should work with an very early version of Git. Now we are first going to load do a module purge. So this is going to clear all the modules. If you're not familiar with the HPC environment, please refer to our training in past 2 weeks. And what I'm going to do is to load Git to my system. Now if type which, it shows I am using the Git 2.17. And so this is actually the slides content on page 14. So this verifies you are currently using a Git version. It's very simple. You're using Git to try to create a repository. And this is the tool ready for you to use. It's now available, right? So we are going to, the first few slides from slides 15 to 16 is about the first time Git setup. So in order for the Git to work with your repository, on slide 15, let me go back to the slides. It asks you to set up your identity. So basically, this tells you, since Git tracks the changes from everybody, so it is important for you to identify yourself if you want to use Git. If you don't identify yourself, Git will refuse to work. Any command you type, it will first ask you to identify yourself. And the only thing you need to provide is your name and your email. It can be anything. If you put Donald Trump on your name, it's going to accept it. You can use any email as long as you identify yourselves, but you have to identify yourself. All right, so I'm going to identify myself first. Let me do a clear. I'm to git config -- global user.name. I'm going to use my name instead of Donald Trump. And second thing you need to provide for Git to recognize you is the email. So simply change the last user.name into user.email. I still change that to my user. Now, after you have done the 2 steps, then Git knows, okay, your name and your email, this uses these 2 pieces of information to identify each user. Okay, I don't know if you can follow the screen, but there's something you have to do before you create any repository. Otherwise, you will have errors. What's the problem? Huh? Check my username already in the system. I already have it. It will not. It will not check if I said it can be anything as long as Git It has nothing to do with your current username. You can use anything. Cat, dog, Donald Trump, Clinton. It will work. It's just something you identify yourself.
This is what I'm confusing. When I have GitHub username.
It's different, and we will talk about GitHub at the end of today's training. It's different from, it's something you identify locally. We will not go to the cloud at this moment. We only work with something on your laptop.
So there's after you set up a repository on your local machine, you have to do this step.
Before you set up the repository, you need to do this. You need to have Git. So there's someone come to Git, and Git need to know who you are. And just need your username and the password, username and email to know who you are. Identify yourself, and that's it.
So the username is associated with a specific repository.
No, it can, but it's not necessary. Oh, if you are confused about that, so we use a global. So after you have configured, use this command to identify yourself with your username, with your email. By default, any future repository you created using Git on this laptop will be using this identity to identify the repository. So you can change the username and user the email for each repository locally, but by default, this is a global username and email identity for all the repository you are going to change in the future.
My first question was, I think I already have those on my machine, but I don't know what not.
Okay, and that's something you can figure out for in the same slides, git config -- list.
I have a code and I have that show something different.
Yeah, it can be different. It doesn't have to be the same as what I show here. It can have lots more information. Does that answer your question? It shouldn't be too confusing for you. As long as you configure your username and email, you are ready to use it. If you don't, it will ask you for it. All right, the next step is try to get help. So the slides for on page 16, just very easy for you to get help config. This gives you a complete manual, gives you the manual entry of how to access the Git config. Or the other syntax is git config -- help. Exactly the same thing. You can also use the man git config. There are different ways to achieve access the same repository of information. But as I said, if you're really confused about the usage, well, nowadays, actually, I don't do this. I just simply copy these error commands, copy the command name and just Google it. Okay, and that's sometimes it's much more efficient than you go actually going through the entire several volumes of the information provided by the menu page. Okay. So these are the some preparations we need to do before we try to actually start creating our own repository. Still have questions? Okay, I assume you don't have any questions regarding our identity. If you are really confused, I can work with you later. But I want to go to the basic usage of Git from next slides. So let's first take a look at the basic usage of Git. First, we want to give you explanation of what is a repository. So here I give you the definition of a repository in Git. This is what is a repository. A repository, or sometimes we just simplify it as a repo. It is a directory that contains all the information regarding the history of your code until code history. So basically, this is a folder. The repository is a folder. It contains all your version information. And even if you don't have other files, if I give you this .git folder, you should be able to retrieve all the version controls, version history of the entire code by just simply utilizing this .git folder. So this .git is very important. If you remove this folder, the entire information are gone. So don't delete this directory at any time. And you will see it. So let's go back to the terminal, and I'm going to try to create my first repository. I'm currently working at this folder, and you can work at whatever folder you want to start with. I want to create my repository with the name, my repo. I'm going to first create a folder called my repo, my repository. And I'm going to cd to that repository. Okay, so this should be an empty directory at this moment. Very easy, simple, super easy. It should be no confusing point at this moment. So I'm going to use the first initialize empty directory command. So after we initialize a empty Git repository, we can throw things into it. So let's first use the command git init. Is my font enough? Do I need to increase the font size? Response. Let me try to change the. So let me first go to my repository, and I have run the git init command. Now it actually does is created a .git folder for you. If you use -ls -a, after you have run this git init command, it creates a .git folder. And that is your repository. Currently it's empty. It has nothing. For your version history, but it'll already have some files in it to work with your version history. So if you further do lsa .git, you can see that it's inside this .git folder, it has lots of files already in there. So these, you don't need to work with these files at the moment, and don't try to change it. You can take a peek at it and see what it actually is. But these are all the informations needed for Git to work with your version history. So this, after you have done this git init, this created this whole thing. It's just a .git. It's the repository created. Now, let's try to create a file. I'm going to create a file called readme.txt. And we will work with the version history of this readme.txt. And this will be the software we are going to work with, the input you'll work with for today's tutorial. I'm going to first edit this readme.txt. I'm going to first open this file, and I'm going to show 2 lines into there. First, I'm going to write it as what exactly on the slides. Git is a version control system, and Git is free software. After you have write these two lines, save it and quit. If I cat readme.txt, now it has 2 lines. This will be the file we'll be working with, its version history. Now, we're going to first add this file to our repository. The command we use is to git add readme.txt. Very simple. Two steps. In order for you to add a file to the repository, 2 steps. First is to use the git add, then use git commit. Provide a piece of information to tell the others or tell yourself what you were doing. So this piece of information is added a README file. Now it's committed. So on the slides, we explained what are the purposes of the 2 steps. First, we add the readme.txt to the staging area. That's something new, and we will explain that later. And some people call the staging area is also called an index. But I think for most of you at this moment, using the term staging area is much easier for you to understand. So we will use the staging area throughout today's training. But I haven't explained that. But first, remember, using git add, we just added this readme.txt to the staging area. And the second command we use is the git command -m. This is commit your changes to the repository with a message -m. And by default, it will always ask you to provide a piece of information to tell you and tell everyone else who work with the repository about what you were doing. So please give this information a meaningful. Please provide meaningful information for this piece of message. Maybe after a while, when you go back to the version history, you have no idea about what you were doing. So please don't type something random, just randomly commit it. It's meaningless. All right, so we have committed our first file, and we have the 2 lines in the file. We have a commit. This is our first change. Before we explain anything else, we are going to push 2 other changes to the version history so that we can work on it. So we are going to make a change to readme.txt. So still remember, in the current file in the repository, we have this readme file with 2 lines. Git is a version control system, and Git is a free software. That's the only information in the repository. So we're going to make some changes to the readme.file. Let's follow the slides. So it's, let's add a distributed word to the readme.file. We save it. And we can introduce a new command called get status. It currently says it's not highlighted red. Okay, it now highlights. It says that readme.txt is changed. Right? Because now the version control system tracks the changes and it knows your change. In order for you to add this change to the repository, still, we are going to use the 2 steps. If you don't remember the changes, since it only prompts you the modified readme.txt, what we can do is using git diff. It automatically gives you the difference compared to your last version in the repository. So it highlights simple, we added the word distributed. Okay. Now, still we want to follow the steps of adding this change to the repository is to git add readme.txt, git commit -m. Since the only change we made to the repository is to add a distributed, so we used add word distributed. So far, anybody have any questions regarding our 2 changes in the version history? We made 2 commits to the repository. One is first we have 2 lines. Second is that we only added 1 word distributed to the README file. Do you know the steps for adding another change? Now, if I want you we want to make 3 commits to our repository, actually to the readme.txt. I'm going to add free software. Git is a distributed version control system, and a Git is free software. What on the slides is we are going to make another change, distributed under the GPL license. So we are going to make the change. Is free software distributed under GPL. This is another change. Now I want to add this change to the repository as well. How do I do that? What are the 2 steps we just talked about in the slides? First, git add, and then do what? -m, and we want to give it a meaningful name. So we added the license info. Is that what I said in the slides? Yeah, appended the GPL. Okay. All right. So we have committed 3 changes. Do you still remember the 3 changes we have made? First, we have an empty file. Then the second commit is I added a word distributed on the first line. Then the third changes is we appended the GPL license to that README file. Very simple changes. 3 changes, but simple enough or complicated enough for us to create a version history for the README file. All right. Now I'm going to gradually go into explaining the concepts, but we first want to take a look at the version history created for our repository. The command we use is to use git log. Okay, it shows several informations. Let's go through that one by one. So everybody please look at the screen. It has a long string after each commit. The first is, I can tell you this is 40 characters long. This is called a SHA-1 hash, as I explained in the next slide. So each commit is identified by a SHA-1 hash. You can Google what is a SHA-1 hash and how it is obtained. But for you to use Git, you don't have to necessarily understand it. The only thing you need to remember is that each commit is identified by a 40-character SHA-1 hash. And it is identified by this instead of a sequence number. Anybody can think of if you use some other version control system, like Subversion, they identify each version using sequence of values, 1, 2, 3, 4, 5, 6. And Git uses the SHA-1 hash to identify each commit. Do you have any idea why we are using this SHA-1 hash instead of why they don't use the sequence of numbers? 1, 2, 3, 4, 5. Sure.
If you have different branches and they want to come back together,
it makes no sense. Yeah, so if this is a distributed version control system, your local sequence of number doesn't make sense for the rest. So they use this SHA-1 hash to identify each commit. It's meaningless to use a sequence of numbers to identify each commit. All right. Also, please notify here is a head. It points to master on the screen. So on the next slide, we explain that a head is a special pointer in Git. This is a pointer to the local branch you are currently working on. So you always work with the head. This always points to the current branch. It actually points to the current commit you are working on, but we're going to explain that later. So just explain the Git log, you will understand a certain of things. So what is head? What is this SHA-1 hash? And actually the rest piece of information are easy for you to understand. It tells what? Who made the changes, at what time, and what you did. Okay, this is author. I made this change at this time, and here's what I did. So what's your question?
Is the hash made from the changes as well as the heading information, or just
it will work with your changes, also work with your files, and they'll probably work with the time you're making the change. So SHA-1 hash, there is a complicated algorithm behind that for you to get a SHA-1 hash. It's explained in the next slide. And Google it how SHA-1 hash is calculated, because it will be a long story if you want to explain that.
No, I just wanted to know what data was used.
Yeah. It will use the information of the file itself. It will also probably use the time also use yourself. So it's a complicated algorithm.
File, I assume, just the changes, right?
It will relate to your file as well. Go search for it. That's a good. Yeah, it will show nothing at this moment. I'll explain why later. Okay, if you use git diff, it will currently show nothing.
This is SHA-256, right?
I don't know. For here, I just want to show this is identifies each commit is a SHA-1 hash. And I also, in the slides, I showed the git log dash one line. This gives you a shortened version of the git history. So you can use the first 7 characters to identify each hash. You don't have to type everyone. To type the entire 40 character, it's a nightmare for you, right? So for you to identify each hash, you just need the first 7 characters. Now, anybody have other questions so far? Still, I try to create a minimum amount of changes in the version history. And we're going to travel through different versions or travel through different commits in the version history. But before we go that, I want everyone to be clear about what we are doing. What we are doing, we created 3 commits on a README file, and we made very simple changes. Now, let me do a clear of the screen. So let's go back to git log one line. If I cat readme.file, if I want to go back to the version without under the GPL license, I want to go to this version. How do I do that? Now, this is a situation that you want to revert your changes. You're working on something, and you just appended the GPL license, and your boss coming to in front of your desk and tells, hey, our software is no longer licensed under GPL. Please remove that. What you can do, you can simply open the file and change that, but we want you to revert to a previous version. Now we're going to introduce the next command is git reset --hard. Remember this command. So we are going to revert to the added word distributed. So remember this command, git reset hard, then followed by a commit. It gives you information head is now at this commit, added word distributed. Now, if you look at git the content of readme.txt, you will see we have reached a previous version, the second commit. Git is free software. Okay, we are not introducing too much commands, but hope this is the command you want to remember. It's how we travel to a previous commit. Have questions? Okay. Now in the morning.
I do have one. Is the in your example, the GC2983B commit, is that still available in the repository?
I will talk about that next. Okay, let's think about this another scenario. In the morning, your boss coming to your desk and says that we no longer license it under GPL. In the afternoon, he changes his mind. He wanted it back. he still want to license it under GPL. How do we do that? I'm going to introduce another command called git. If I do not introduce the next command, if we use simply git log -- one line, the previous command, the last commit is not listed, correct? So we're going to introduce next command, git reflog. Did you find it? It's still there. So whenever you want to find a commit, use git reflog. Now, you can work with your crazy boss and revert your previous version. It's the same command we will be using, git reset --hard, since we have that commit. If you do a cat readme.txt, you will see that under the GPL is back. Did I answer your question? Yeah. Have questions so far? It should be git log shows all the logs before the commit, but reflog shows all the history of the commit numbers. As long as you make a commit to the repository, it's there. It's very difficult to lose. It's almost impossible, very, very difficult for you to delete a commit. As long as you throw something and you commit it, it's almost impossible for you to lose it. And that is the purpose of the version control system. So everybody should be very clear about what we have done so far. We have initialized a repository. We added a file to that. We also committed changes to the repository, and we also traveled through different versions. We showed how to revert to previous versions and go back to previous versions as long as it is in the commit of the repository. So let's go back to the slides and do a very short summarize. So, so far, you should get yourself understand how do we initialize a Git repository? How do we add files? Actually, how do we add changes to the repository? What are the 2 steps we do a commit? First, we do git what? Add. Then we do git commit, right? And remember the 2 steps, and that's important because we're going to explain why we're using the 2 steps. And we also show how do we travel between different commits. That's how you revert to different versions. How do we do that? What's the command we use? Git reset hard, right?
In your examples, you said git add and then the name of the file that you're going to add to staging.
Yeah.
But the system is keeping track of last modification dates and things.
We are going to explain.
Git add would it do everything has been modified?
We are going to explain that in.
Oh, I'm sorry.
Yeah.
Look at your notes.
So that's a good question. That you are following what I'm talking about. We're going to explain that in next part. Okay. Understanding the staging area. Okay, so it's good because you are thinking. All right, so since he asked this question, that means we have to explain the staging area. We're going to explain the three main sections of Git. We have to explain the directory .git. It stores all the information of your project. Whatever changes of your files, of your source code in the repository. This is the .git directory contains everything, every information, all the metadata. This is the repository. It contains all the version history. And then the second concept is the working directory. Here gives you a definition of what is a working directory. A working directory is a single checkout of one version of the project. And that is to say, the working directory consists of files that you are currently working on. So you have all the directories, all the files is your working directory. Everything in your current, you are currently editing is your working directory. Everything under that folder. All the files you see, all the files you're working at is your working directory. The last concept is what we call the staging area. The staging area is a file that stores information about what will go into your next commit. And as I said, sometimes it's referred to index, but I think it's more easier for you to understand this is called staging area. So as long as, let's review the workflow of Git. We have remembered the two steps we need to work with adding, doing a commit. We first do a git add. Then we do a commit. When we first add, you add a snapshot of your files to the staging area. Then when you do commit, you put the snapshot of the staging area to your repository. And once you do the commit, it's permanently added to the repository. That's a further explanation of the two steps we work with doing a git commit. We first add, then we do git commit. Two steps. There is a command you can jump out of a staging area directly to commit, but that is not a focus. And I don't want you to do that in that way while using Git, especially at the very beginning. I want you to follow the two steps. This gives you a better idea about the staging area and about how actually Git work. So use the git add and git commit. It seems a little bit complicated, a little bit cumbersome at the very beginning, but it helps you to understand Git. So remember the two git add and git commit and what does each step represent. Now I'm going to answer your question. We'll first say git record changes to the repository. It's not actually file. So when we do git add file, it's actually record the changes of the file instead of file itself. And actually there are two types of files in terms of the Git. One is untracked files and the other is tracked files. Easy to understand. First we create a readme.txt and we use the git add to that repository, right? To the staging area, then we commit it. When we do git add and git commit, then we put that file from untracked to tracked. So you need to manually add files let Git know what files you want to keep track of. Keep an eye on that. If you don't add your files to the repository of Git, Git will not take care of that. So basically there are two types of files. One is untracked file, the other is tracked files. Accordingly, since we say that Git records changes to the repository, there are two types of changes. First is we add a new previously untracked file to the repository. That's what we did at the very first step. Git add readme.txt. The first thing, we add some content to the files and we add it to the repository. That's first type of change. Second type of changes is that we added a word of readme.txt distributed. When we do that type of change, this is a modification of a file that is already under Git tracking. Git already is looking at the changes of the file. And we just want to record that change. So remember the two types of change. One is we add a new file. Second is change of a file to the Git radar. This is a picture I actually grabbed from the Git book, SCM book. And I think it actually gives you a better idea about the difference between untracked and tracked, but I think should be easier for you to understand, right? In order for or in other words, in order for Git to track the changes of your files, you need to let Git know that. How do you let Git know that? Is using git add and git commit. Now, think if you just follow the slides, you probably don't still have a very good understanding of it. And let's do some actual examples to try to help you understand the staging area. Let's create another file. Currently, there's only one file, readme.txt, and we have made a couple of changes to it. And currently it's in the directory. Now, let's create a license file. lice.txt. Okay, I'm going to create this license file, and we're going to add one line. This is a license file. We just add one line to it and create a new file. If we do an ls, we have two files. One is license.txt and the readme.txt. Okay, that's one operation I did. We simply add a new line, license.txt, to the current directory. Is it currently in the repository yet, as we explained before? Is it currently in the repository? No. Git knows nothing about it. Now, let's make a change to the readme.txt. Let's add another line to the file. And in the slides, it says Git has a mutable index called stage. This is the official word called the staging area. And we save it. Do a cat readme.txt. We just added this line. We don't want to use complicated word, mutable index. What is that? It's the staging area. So remember the two changes we made so far compared to our last commit. First, we added a license file The second one is we add a new line to the readme.txt. Now, let's use the git status. It shows clearly of the two type of changes we have made. What are the two changes? First, we change the existing readme.txt, add one line, right? The second is we have untracked file, license.txt. Let's do the commits and try to commit those changes to the repository. So let's first do git add license.txt. And what are the second step we need to commit it? Commit -m, say I did a license file. Now, what did we actually commit? If we use a git status, what did we commit compared to the last status? Last status says that we have one changes not staged for the commit, and we also have untracked files. Now, after we have done git add license.txt, and we do a git commit -m, the untracked file is gone in the git status information. So that means the license.txt, this untracked file, this change is added to the repository. But the change of readme.txt is still not in the repository. In order for us to add this change to the repository, we need to do another add and a commit. Let's do that. -m added index info. Let's say staging info. Now, if I do git status, everything is committed. So remember, let's do recall what we did. We used the two git commits to record the changes of the two files. One is we adding a new license.txt. The other is what? We record the last change we made to the readme.txt. Confused? Okay. If you don't understand the staging area, you don't understand the Git. The Git is very important, and the staging area is an important concept in the using Git. If you simply
No, I'm sorry. Go ahead.
okay. Now, you have question.
There's only do one thing on the staging area.
No, it can be multiple things. That's why I said Git commit changes. Changes can have lots of changes. I demonstrated one thing at a time to make things not too complicated. You can get one commit can be 10 files, 100 files at the same time in one commit, but something we need to avoid. In reality, if you do software development, you want to do small commit instead of large commit. Why?
Because if you need to roll things back, you don't want to roll back a lot of it.
Yeah, if you want to compare the difference, you really want to you be able to manage to keep a good idea about what's the meaning of each change.
Another good reason to do that is if you break something
Uh-huh.
and you have lots of smaller changes,
Yeah.
it's much easier to figure out
What changes.
change broke it.
Yeah. So if you do large commits, it's very discouraged. We discourage you to do large commits.
Although I have read that a commit should be, it should be a working statement, basically.
Yeah.
You know, you don't want to make one little change to a commit.
Yeah.
And then when you're debugging, find out that that's an error and have to go back and change it.
Yeah, that's a something stage. We also talk about the working state in next part. So don't worry. But
Can you use? And I understand. I'm with you on the small changes thing, but
yeah,
just out of curiosity, can you use wildcards in the add?
Yeah.
Okay.
You can use anything you want. You don't have to manually add one file to the get. The reason I didn't use any wildcards in today's training is because I want to keep things simple. Yeah. Right? You can use anything. You can use regular expression, xargs, grep, and work with those different to add different kind of files into your repository. There's no problem.
So I think maybe what you were getting at with the adding something that's working.
Yeah.
That's something that's usually handled by branches.
Yes, exactly.
Later.
We will cover it later. And also Git stash. That is something you can work without a working state, and we will detail that later. So you have a good sense. And we will solve your problems in the later slides. We are a little bit out of schedule, so let's go back to the slide 34 if you're still with me on the 34. Now, let's still work with staging area a little bit, okay? Now everything is committed. I have nothing to show in the Git status, but I want to make some new changes. Git tracks changes. Okay. So remember what I do? I currently added one line git tracks changes to the readme.txt. Then I do git add readme.txt. Okay, everybody please heads up. I want you to look at the screen and pay attention to what I'm doing right now. This is a very important step for you to understand the staging area, especially for tracking of changes, okay? Now, remember what I do. I added one line to the readme.txt. And after that, I did a command called git add readme.txt, right? Now, if I do git commit, I made another change to the last line. If I do a git status, you see the green one shows changes to be committed. The red line shows changes not staged for commit. If I now do a git commit, I have committed git commit -m tracks changes. What is currently in the repository?
Whatever you did before the add.
So currently in the repository is git tracks changes. It's not tracks change of files, right? If you want to add the second change, what you need to do? Do another git add, git commit. So it's very often you will see status like that, modify this one, modify that one. Keep in mind, you are always working with changes. Any changes, if you want to commit to the repository, you need to follow those 2 steps. And you can also do git diff. Always shows your current working directory difference with what? With the staging area. All right, so I understand the staging area at this moment might cause some change. So please do your homework by repeating those steps from slide 33 to slide 35 and try to understand what I'm trying to emphasize in those slides. Is the staging area, is the concept of changes and how we commit to those changes.
Before do the git commit, you want to see and it's in git diff.
Yes, okay, that's a good question. So currently you have the changes not staged for the commit, right? If I do git add readme.txt, then I do a git diff, nothing is going to show because the change of readme.txt of change of files I added last time was just added to the staging area, right? If I want to compare the difference between the staging area and the repository, simply using git diff is not going to work. So in order for us to view the changes, difference between the staging area and the repository, you need to use a staged. This shows exactly what's happening to the repository that is going to be happen for the repository. Right? And we're going to further explain that in the next section of undoing things. You will have a better idea of that.
So a diff, a simple diff shows the difference between
the working directory.
The working directory and the staging area.
Yes.
And diff staging, git diff dash stage
shows
the difference between the staging area
and the repository. Exactly. Since you understand this way, you understood it. And we will be further explain that in the next stage about undoing things. So let's do a short summarize before we go into that. We showed 2 usage of git add so far. One is to add new files, right? Put the untracked files into the Git radar. Now Git knows it if I use git add. And any changes to the existing file we add it is to add the changes for files to the staging area. These are the 2 changes. There will be the last other change is about to resolve a conflict we will be using git branch, but we will explain that later. So there are actually 3 usage of git add, and we have used the 2 when we use the last one in the branch when we talk about the git branch. Okay, everybody clear about the concept of working directory, staging area, and a repository? And please still work with that a little bit more after the class, so you have to really understand it. Because if the first time you use Git, especially with beginners, the staging area is the most confusing things. So staging area is staging area for changes. It's not for the snapshot of a file. Now let's go to the next fun part. Undoing things. Did I commit it? Let me commit it. All files. All right. So currently, everything is committed. Let's go to try to do undoing things. Now, let's first look at the readme.txt. All right. Now, supposedly this is like midnight, 2 o'clock, and you are drunken and drive. You're drunken driving, and you wrote something funny. Okay. You wrote something, and you're chatting. You're typing something. You're supposed to chatting to your friend, but you actually wrote that to the working file, and that's going to be in your repository. Now you do a git status, and if you are not that drunken, you did a git diff. Oh, I need to undo this change. How do I do that? Okay, if you use the git diff before you do a commit, there's still changes. There's still chance of you to getting it back. Okay. So instead of losing your job directly, you need to revert this change. How do I do that? There's a command git checkout -- readme.txt. So by doing that, we are using the version of the file in the repository to replace the current version. So by doing this git checkout, we are using the version in the repository, which are the versions that are without this dangerous line. So after you do this, if you do a cat, it's back. Okay, now you're okay. That's one type of undoing things.
What is the dash for?
Dash for is specified for a specific file.
For a single file.
For a single file. You should be able to do that with a folder that go search for that later, but I'm currently just trying to explain the concept of undoing things. Now, if you drunk a little bit more, all right, let's do readme.txt. Still, you are chatting. My boss is too bad. Okay. Now, and you, because you drank a little bit more, you did even one more thing bad. If you do git diff, you will see nothing. And but the thing is not too bad. You have to diff this staged. Oh, I realized that before I do the commit, I realized I need to revert this change. So this change, my boss is stupidx, is currently this change at where? Isn't it a repository? I did a git add.
Okay, no, it's in the stage.
It's in the staging area. It's not too bad. So in order for us to revert this change, we need to first unstage it. Now, let's do a git status. It gives us the command to unstage it. Git reset head file. So we need to first unstage it. Now, where is this change? It's in the working directory, right? Now we can do a simple thing as the previous git checkout -- readme.txt. We are safe now. You don't need to worry about losing your job. Okay. If you committed that, it's very difficult to have that commit out of the repository. That's beyond the scope of today's training. So be careful. If you really type something bad in the commit, it will be difficult for you to remove it. So if you hate your boss, don't commit it in your repository. Especially if you're working with repository in the cloud, if you pushed it, if you don't have the permission, then there is no way to get that back. You need to really to find next job. Update your resume, yeah. But if just a mistake, how do we revert it? We just talked about that. If just a mistake, how would you revert to the last commit? Git reset hard. Then followed by commit none. That's correcting a commit.
The git checkout.
Git checkout use the current version of the file in the repository to replace the current version in the working directory.
So it can discard both on stage and.
No, it's only for to replace the version in the working directory. If you want to work something in the staging area, you need to first unstage it. And this unstage command is git reset head. That's how we unstage it. So just keep in mind the staging area concept, okay? To keep your job safe. We are running a little bit out of time, so I want to skip the delete file and the rename file. These are very easy operations and should be able to do that by yourself, by following the slides. I want to do a short summarize of the change management. In order to better for you to work with the changes, first try to understand the staging area. And in order for you to have a better understanding the staging area, think about how do we discard changes in 3 different cases. First, in the working directory, second, in the staging area, and if it is committed, how do we revert to the last commit? If your boss didn't learn how to use Git, it's still safe for you if you have something bad, okay? If you doesn't know, let me ask you this question. How do you find that bad words? If you are the boss, how do you find that bad word in the history, in the repository? What command usually?
Grab.
No. How do you grab? Grab for what?
Or whatever that word you're looking for.
It not disappear because the employee has reverted to the previous version. It's not there. It's not in the current working directory. How do you do that?
No, I would grab the actual,
Stupid.
.git. I mean, .git, subdirect.
You need to use the git ref log to get it. Right, that's something we talked in the first part. Because git ref log shows all the commits in all version history. That contains everything. So as long as it is committed, it's very, very difficult to get it, to remove it out of the repository. It's still possible. There's a complicated way to hack it, but it's out of scope of today's training. All right, so let's talk about the Git branch. And I want to just use very simple example to show two type of branch. Because if you want to test out some new functions and you need to work on these new functions for a period of time, and when the testing of the new functions is mature, you want to merge the mature branch with the development branch as we have specified, demonstrated in these slides, right? And this actually shows a type of workflow that's typically in our development. So you have a main branch, you have different commits. This branch is good, I release it. This branch is good, I release it. But at this stage, I want to do a test stage, a test development of a different branch of different function. And I work on it, and I have this. I need it for several commits because I'm completely developing that. After this, after this new function is mature, is well tested, I want to merge it to the main branch. That's our typical workflow for developing new functions, right? I want to show you the way to do it. So there are two types of merge. So the only thing we want to work with different branch is to merge. One way of merge is what we call fast forward merge. And this is very simple case. Let's look at this picture. So you have a master branch. At a certain point, your boss comes in and asks you to develop a new branch. And I create a new branch. And I worked for a few commits. And now at this point, it's well tested. The new function is ready for release. I want the entire group who is on the master branch to merge with this development branch. Everything's fine. This is a very simple case. You just need to ask this master commit to go jump 2 steps further to catch up with this new development branch commit, right? So this is a very simple change, and that's simple, what we call the fast forward. Just forward the head of the pointer of this commit to merge with that development branch. This is a very simple case, and there's actually nothing too many things we want to show here, but I want to give you an actual example of doing that. So let's still look at the README file. Let's do a clear, do a git status. I make sure there's nothing not committed yet. So for example, at this point, your boss comes in and he asks you to create a new branch to develop a new feature of your software. So what do we do? Git checkout -b means we create a new branch called dev. This is one command showing two operations. One is create a new branch and called dev, and we switch to it. If we use the git branch command, it shows that you currently have 2 branches. One is master, one is dev, and you are now on the dev branch. Now you can comfortably develop new branch because it will not interfere with the master branch, right? So now I'm working on the new branch, and I'm going to develop a new feature. So the new feature in our example is easy. I'm going to add a new line to the readme.txt saying that creating a new branch is quick. Okay, this is just a new feature I want to develop in my software. So now I want to commit that git add readme.txt git commit -m branch text branch test. Now, if I do cat readme.txt, this has the new line of creating a new branch is quick. Now, my new feature is done. It's committed. And now I'm telling my boss and the entire group, we can now readily merge this new feature with the master branch. Let's switch to master branch using git checkout. Okay, we can first verify what's happening on the master branch. Still, for the master branch, it's still at the last stage. It doesn't have our new feature. Right? Very clear. We are on the master branch. We don't have the new feature, which is the new line we added to the README. Now, if we want to merge the new feature from master branch with the dev branch, we do git merge dev. You will see it's updating this commit to this commit, and it's a fast forward merge. The master branch just jumps one commit further to catch up with the dev branch. It's where everything happens in a line. It's linear. And we can use a command to verify that. Git log --one line --graph. It shows now the dev branch and the master branch, they are at the same point. After the new feature is done, we can drop the development branch. Git branch -d, delete the branch called dev for bookkeeping. Okay.
I just tried doing git log one line .-s graph, and git log just one line.
Yeah.
And I got the same exact output from both of them.
One line without graph because it's fast forward merge. It's almost the same thing as you git log without graph because the two branches at the same point. It's a line. You won't see anything. And you will see something after we do the three-way merge.
Right.
So that's the second. We're going to talk about a more complicated case with a conflict, what we call the three-way merge. So before we work on that, we need to look at what's actually happening for the three-way merge. So this is much more common than the fast forward merge. In many cases, you cannot do a fast forward merge. For example, now at this point, you are developing a new feature and you reach this commit. At the same moment, you spend a week, the other people for the master branch, they reached this point. Now, you are ready and they are ready, you are going to merge. However, there will be a problem at this point. What is the problem? There can be conflict. You are editing this line, he's editing the same line, and the contents are not the same. So what's gonna happen? You need to resolve the conflict by yourself. There is a step, additional steps, as additional step for you to merge the two changes. And let's try to simulate that situation. In the how do we do with the three-way merge? Okay. So let's first, since we git log, okay, our our working directory is clean, so let's now let's first create a dev branch. Git checkout -b dev, and in the readme.txt, creating a new branch is quick and simple. This is the changes I made to the dev branch. Compared to the last one, we just add this and the simple. Okay, let's save it and commit it. Commit, add readme.txt, git commit -m and simple. That is for the dev branch. Now, let's switch to the master branch. In the master branch, they did something like this, and simple. They also committed. All right. Now, both two group of people say, we are ready to merge. Okay. On master branch, I'm going to merge with the dev branch. There is conflict. It shows conflict and automatic merge failed. You need to manually fix the conflict, then commit the result. That's clearly instructed by Git. Tell you what you need to do. All right, so let's try to look at readme.txt. It clearly shows what's going on. It tells us the difference, and now it's your turn to fix the conflict, resolve the conflict. So I just want to resolve in that way, and that's it. Delete all the unnecessary information. After I have resolved my conflict, git add readme.txt. You can do a git status. All conflict may fix, but you are still merging. This status is currently still in the staging area. then I do a git commit.
I'm sorry, I missed something. Whenever you corrected the error,
Yeah,
did you just,
save, quit.
no, I mean, in the file where you had the two different
Yeah,
versions,
delete them.
did you just put in a single version?
Yeah.
Okay.
And the single version is the final version you want to commit. You are responsible for organizing the contents in the file. If you don't remove those chevrons regarding those head and def, and then it will be in the commit. Git thinks that conflict is resolved. As you have saved it, you need to add that conflicted file because you resolved that conflict. On my side, it's ready to commit. I would say resolve conflict. A little bit over time. We might be a little bit like 10 minutes or 15 minutes over time. Is that okay for you? Yes, I want to talk about Git stash. Now it's okay for me to commit this resolve conflict. Now I have resolved this conflict. We can verify the path of the two branch by using the command git log -- one line -- graph. It clearly shows we create another branch and we merged by resolving the conflict. So actually git log -- one line -- graph is very helpful for you to have a better idea about how the different branches are organized, how do they change over time. Now we are going to talk about the last part, git stash. Probably this command somebody is kind of afraid of to use because they didn't understand it. So I'm going to give you a very simple example to help you understand what is git stash. So when you are in the middle of anything, something, for example, you are comfortably working with your dev branch and you're trying to develop a new feature. At some point, you are in the middle of doing something and your boss suddenly come to your house, suddenly come to your desk and ask you, I need you to quickly fix one bug for me in another branch, but I'm not ready for a commit yet. How do I do that? If I do a commit, it's not ready, it's not working. How do I do that? So let's try to mimic that stage for that situation. For that situation, the best resolution is use the git stash. It packs all the current working directory to a stash state. And now you can comfortably switch to other branch, do your quick fix, and come back to your current branch, and then you have everything back to your table. You continue working on your current state. Let's work on that. We are going to develop a new feature. Let's first check out dev. Okay, So we are going to add a new feature or text. Developing new feature. I'm not ready yet, not ready for a commit. But now your boss comes in and asks you, okay, please quickly fix this bug for me. Okay, your server is broken and this is very urgent. You need to discard everything you have done at this moment and you need to work on fixing that bug. Now, I don't want to lose the status of my current work. So now for in Git, it's easy. Git stash. I probably need to do a git add. Yeah, git add. Otherwise, Git is not going to aware of that. Feature.text. Git status. Okay, and you do git stash. If you want to do a git status, everything is clean because it's packed. You have all the current not ready for commit status packed to the stash list. Now you can comfortably go to the master branch. Check out master. You look at the README file. You fixed your bug. Git add readme.txt, git commit -m. I fixed my bug. Now, I am now at the master branch, right? Now I've done my work, done my fix. I want to switch to my dev branch, continue my work. In order for me to recover that not ready for commit status, git stash list. It stashed me for a status called and simple, whatever. We are trying to develop my new feature. Currently, it doesn't have the feature.text, right? We'll do git stash pop, or what I want to do is to git stash apply. You can copy paste this status -- index. If you do a git status, you can still working on your feature.text like that. This is the most typical case, how you use git stash. Packs all your status, current status, which is not ready for commit. You can switch to other branch and work on something else. After that, you unpack that state, so you can continue working on that state. All right, so basically, this is what we are going to talk about in branch. It's a very powerful feature. It's actually also very easy to use. I want to do a very short summarize. There are some branch strategy also in the slides that even sometimes you are do fast forward merge. When you do actually commit, it will remove all the branch information. So we try to avoid using fast forward merge. We do a -no-ff to avoid to delete those branch information. So if you do a no fast forward merge, it will always have this branch information retained. All right. So let's do a short summarize of branch. Okay, here's another strategy before we do the summarize. So in reality, for the branch, the master branch is always stable. This is the branch you use to release your software. Because if you want your user to release your software, each commit, each release needs to be very stable. Okay? And all the development needs to be in the dev branch. And each person can have his own branch, have his or her own branch to work on something even more trivial, need testing, audacious. So in real case, branch can be kind of complicated. Actually, it's very easy to use. But just need to remember, each time we want to merge different branches, in many cases, you need to resolve the conflict. And I have demonstrated the procedure of resolving the conflict. Okay, so let's do a short summary of doing the Git branch. So we show the two types of merge. One is the fast forward merge, and the other is the three-way merge. And the only thing you need to pay attention to is you need to resolve possible conflict in a three-way merge. There might be no conflict, but there can be conflict raised in the three-way merge because the two branch has the common ancestor. When they are editing the same line, there will be conflict raised. Also, we talk about the branch strategy, and we also talk about interrupted workflow. If you are in the middle of anything, you are not ready for a commit, what command you need to use to pack your current status is the git stash command. All right. Since we are running out of time, the last part is work with the Git remote repository. And actually, this is the simplest situation, simplest thing that's in the whole slides. Do you want me to demonstrate or you work on yourself? Do you want me to demonstrate how to use work with the remote repository? Raise your hand. Okay, let's do it. Now, let's go to branch. Git checkout master dash m. Okay, let's just I just want to push the current repository to GitHub, and so that it's in the cloud, everybody can see that and then use my branch. So hi, I want to demonstrate how should I do that. Actually, it's so simple compared to the previous contents in the slides. This is the simplest part, easiest part, but let's still do that. So let's go to GitHub. I have an account registered, and if you don't have account, please register for one. And I don't want to show the step of register. This is really simple, okay? So I want to create a new repository. Okay, how do I create a new repository? Here is the button you need to click, create a new repository. Give it a repository name, my repo, great repo. Okay, you can now, before last year, you don't have the private option. And even if you check the private option, it will ask you for the credit card information because it's not free. But now, GitHub supports private repository for less than 3 people. So if you have a really small group and if you are, your advisor only have like 2 or 3 students, a perfect situation, you can use private repository if you want to make money with your software. Okay. And that's real case. Let me make my repository public. This is really simple. Because since we are editing on a README file, I don't want to have a README file. And you can put some description, my first repo. And I just click create repository. Okay, now it gives you directly the information for the commands you need to use to push an existing repository from the command line. So basically the first step is a brand new repository. That's not the case we've been using because we already have our Git repository set up. We want to have our my repo pushed to GitHub my Git repo so that everybody can use it. Now, it showed the two commands of how do you push the repository to GitHub. So I do git remote add origin this URL. So let's just copy paste this command from my current repository. What's the second command that they use? Git push u dash u origin master. Username. Okay, now it's pushing my commands, pushing my contents to the remote repository. So if I now look at the GitHub repository, it has all the information. Now, your code is even safer because it's in the cloud. All right. So there are other how to view your remote repository. It's very easy how to update it. I leave it as a homework how to push the dev branch to your repository. So that's basically we are done with today's training because working with remote repository is kind of, I think it's quite simple with GitHub. So I'm not going to spend too much time on that. Let's do a short summarize of the entire lecture today. We talk about why we need to use Git. The primary purpose is track your changes and manage your changes well. And also explain why you use a distributed version control system. And we also talk about how to use Git locally, how to create a repo, and how to travel through different version history. And also we talk about how to create and manage Git branch. And we also talk about in the branch, we talk about how to do fast forward merge, how to do three-way merge. And we talk about a little bit about how to manage your branches and how to work with the remote Git repository. Hope you have a better understanding of how to use Git and how to use actually with GitHub. Okay, so this is end of today's training. If you have questions, you can ask me. And before you leave, make sure you sign up for the on the sheet and then fill out a survey form for today's training. That's the only thing I want you to do. So we have, you can give your feedback of today's, what I talk about in the class. Thank you for attending.
Thank you. Please fill out that form
For today's training, thank you. And this is important for us to keep our training sessions alive.
Are you going to do like a Git flow training? What? You're going to do Git flow training?
Git flow training?
Yeah, Git flow.
What is that?
You're blocking out your branches and your master, your pull request, does all that for you.
I don't know. It depends how many users request for it.
Okay, how do we request that?
If just one or two people, it will be difficult for us to like you have.
So everybody Git flow.
10 or
10 more.
10, about 10 people, then we can probably try to format.
Okay, thank you.
Thank you. Make sure you fill out the survey form. any questions, you can ask me now, or you can send the emails to syshelp@1.org.
So, so once you've created and copied your repository to the remote repository,
Yeah.
How do you check out from the remote repository?
Git pull, that is on slide 73. And there's a bunch of commands because we have limited time.
Yeah, sure.
So look at the slide 73 and use the Google it for Git pull of how to update. Basically, when you work with remote branch, you work with multiple clients and you work with different people. There are different other rules, and that's kind of beyond the scope of today's training.
Okay.
So
Thank you.
thank you for attending.